Here is a quick lesson on how to determine where a function is increasing or decreasing or staying constant. I've drawn this graph here to use as one to learn the ideas from. A graph is increasing whenever as x gets bigger, the y's are getting bigger. So for instance, anytime I move from left to right, the x's that I'm encountering on the x-axis are increasing, and I'm looking at the trend for the y's. Notice they said, where is a function increasing? So what they're trying to do is they're trying to have me identify the regions of x that have the y's getting larger. So it looks to me like if I were to go left to right, the graph is going up and up and up as I go left to right until it reaches this distance over right here. So I would say from the x's being -5 to -4, you can kind of see this is not drawn to scale. It looks like it's climbing constantly, going up, kind of like going on a roller coaster and climbing a roller coaster. So using the interval notation that we've used earlier this year and all of last year, I want to say all the x's from -5 until -4. I should not include the -5 because the open circle implies that that point is missing. So -5, parentheses because it doesn't include it, and to continue until the x's hit -4. And that includes that value. And then what happens, now the y's are decreasing or going downhill as I move from left to right. So this is actually a place where it's decreasing. I'm just right now going to list the places where it's increasing. When it hits here, it doesn't change, it stays level. Then it decreases for a little bit more, but I can see that it starts climbing again once it gets from this x value and on. So I would probably say here and starting at the distance over of 6 and continuing on to positive infinity, because this is going to continue outward. So what we have here is we have the intervals, there are 2 of them, where the graph is increasing. They often ask you to identify the regions where it's decreasing as well. So for decreasing, I can see that the y's are going down as I move from x being -4 until I get to -1. So we would say from -4, it doesn't really matter if you include the endpoint or not. -4 until it gets this far over, which is -2. -1. So focus on the x's. So it went downhill when x went from -4 to -1. Here it doesn't go downhill, it stays constant, but it starts going downhill when it reaches a distance over of 3 as well. So starting again at 3 and continuing to 6. Once I get beyond 6, it starts climbing again. That's why I included that in that other interval. So again, with intervals, I'm not really concerned about whether you use parentheses or brackets. If these were all parentheses, that would be fine with me. However, I got to make sure not to use a bracket with a -5 because that point just doesn't exist. If I ask me to find where it's constant, because that's all a graph can do. It can either climb, or it can go down, or it can stay level. And it seems to stay level from here all the way to here. So the constant would be from -1 in the x direction all the way until it gets to 3. Again, this is not drawn to scale. And I had the freedom to include these in parentheses or in braces or brackets. So that would be fine, the way it's written. So we have identified all the places where the graph was climbing, all the places where the graph was going down, and we also identified where it was constant. I hope this video was helpful.